Now, a couple of things. I'm trying to get your grades in, but you're going to have to give me grades to put in. Some of you are moving really slow. Not anyone here per se, but some of your other classmates are moving really slow. And I don't want to put in zeros, so give me something to work with, okay? And today what we're going to be talking about is the quadratic formula. So this is the tail end of all of the quadratic stuff. So if you've not done, or if you're just beginning the quadratic stuff, all of the previous videos that we've talked about, like the square root property and the completing the square, those are already been covered by our previous meetings. So today will be the last section on quadratics. If I get through it today, I might not get through it today, may bleed into tomorrow, okay? So let me go ahead and share my screen. Okay, everyone see my screen now?
Yes, sir.
All right, so let's talk about something about the quadratic function, okay? Or parabolas in general. So I'm trying to look for a device that I can throw, something I can throw. Okay, so let's take a pencil, right? If I throw it from one hand to the other, right? Notice it makes an arc, right? It makes an arc. Now, when I throw that pencil up and catch it with my other hand, which I can't catch, it makes this shape right here. Okay. And we said that this shape is known as a parabola. Okay, parabola. And a parabola is the graph of a quadratic equation. So all quadratic equations have this shape as a parabola, okay? Now, a parabola can go one of two ways. It can open upside down like it does now, or it can open up, which is a normal shape like this, okay? Now, the vertex point for parabolas is that point we talked about where everything changes, right? So when we have a downward facing or an upside down parabola, the vertex point is the point where it stops going up and starts going down. And this vertex point right here is the point in an upward facing parabola where the graph stops going down and starts going up. Okay. Now, that point, the vertex point, has a significant value. Okay, so if we have an upside down parabola, the vertex point is known as the maximum point. And when we have a downward facing parabola, the vertex point is known as the minimum point. Okay, so let's talk about the upside down parabola first. It's called the maximum point because that's the highest point you can get on that parabola. And remember that point has an x coordinate and a y coordinate, okay? That x coordinate node is represented with the variable h and the y coordinate variable k, okay? Now, the x coordinate tells you where the maximum occurs. And the y coordinate tells you what the maximum value is. Okay. Now, in a regular facing, upward facing parabola, the vertex point is the minimum point because that's the smallest point, the lowest point of that parabola. Okay, again, has coordinates hk, H being the X coordinate, K being the Y coordinate. So again, the X coordinate tells you where the minimum point occurs. And the K tells you what is the smallest value, what is the minimum. So remember, we talked about this in class, that any function or any equation is a machine, okay? It's kind of like a juicer. You put in oranges and you get orange juice. You put in apples, you get an apple juice. Or a wood chipper, you put in oak, you put in an oak log, you get oak chips. You put in, I don't know, give me another tree name. A cedar log, you get cedar chips. Now, so an equation or a function is like those machines, but what you input is the X, and what you get out is the Y. Okay. So in a vertex, the H is what you're plugging into the equation. The K is what you get out. Okay. So the H is where the maximum value occurs, or for what value of X. What value of X gives you the maximum value? And K is what that maximum value is. In an upward facing parabola, it's the reverse. H is where the minimum value occurs, or for what value of X gives you the minimum value, and K is what the minimum value is. So let's take, for example, a situation like this. Okay, here's a parabola, or here's a quadratic whose graph is a parabola. Can anyone tell me what the vertex of this parabola is? What is the vertex of this parabola?
Three and one.
3, 1, right.
Negative 3 and 1.
Not negative 3, 1, 3, 1. Remember, the standard form is AX minus H squared plus K. So as long as H is being subtracted, H is positive. Now, if H is being added, then it's negative. And K is the reverse. If K is being added, it's positive. If K is being negative, is subtracted, it's negative. Okay, so what does that mean? That means now which way does this parabola open? How do I know which way the parabola opens?
It's going to be...
Does it open up or does it open down?
Oh.
It opens up. And how do I know that?
Because the 3 is positive.
Mm-hmm. There's a leading coefficient. Remember, the leading coefficient tells me which way it opens. And if it's positive, that means it opens up. That means the vertex, as it opens up, is a minimum point. So if I graph this equation on a coordinate plane, this is how it will look. And this will be your vertex. So it is a minimum point. So what does that mean? That means the smallest output, or the smallest value of y that this function will give you, is 1. It will occur only when you plug in 3 for x. If you plug in any other number for x, you're going to get something larger than 1. And that's where it doesn't make sense, right? Because, like, what if I plug in 0? 0 is smaller than 3, so it should give me a smaller value for y. So let's see what happens. So we plugged in 0 for x, and we got negative 3 squared plus 1. Negative 3 squared is 9. So my y is 10, which is a lot larger than 1, okay? Does everyone see that? Even though I plugged in an x that's smaller than 3, my output is a lot larger than 1. So, key point, vertex tells you the minimum or maximum value. The x coordinate of the vertex tells you what input or where the minimum value occurs, and the y tells you what is the minimum output. Right? Now, I can use this in word problems. So say, for example, I have a situation like this.
Excuse me.
So, for example, here, a word problem will be something like this. You throw a ball, okay? You throw a ball, and the equation for the way that ball is thrown is given by this, where t is the time since you threw the ball, and y is the height of the ball. And we want to know what the maximum height of this ball is going to be. So imagine like it's a football, you throw it, and it's modeled by this equation, and you want to know what's the highest point the ball is going to reach. What's the maximum height of the ball? And you not only want to know what the maximum height of the ball is, but you also want to know how many seconds after you threw it will it reach its maximum height. Okay. So the way we will tackle this is this. Okay. So you look at it and say, okay, well, this thing is, let me see, hold on one second. Okay, so you'll say, okay, this thing is a quadratic, and its leading coefficient is -16. And because its leading coefficient is -16, that means it opens down, which means it looks something like this. Okay, that means the vertex is a maximum point. Okay. So because the leading coefficient is negative, I know the parabola opens upside down, and that vertex is a maximum point. So if it's a maximum point, the x-coordinate of the vertex tells me when that maximum point is reached, and the y-coordinate of the vertex tells me what that maximum value is. Okay, so now we go back to a couple of lectures ago and say, okay, how do I find the vertex of this parabola? Well, remember the formula for vertex. To find the formula for the x-coordinate, it's -b/2a. So in this equation, a is -16, b is 64, and c is 10. So when we plug it in, we get -64 divided by 2 times -16. And if we do the math, -64 over -32, which is 2. So that means the x-coordinate of the vertex is 2. That means it's going to reach its highest point. The ball is going to reach its highest point in 2 seconds. Well, that answers one question, when it reaches the highest point, but it doesn't answer the second question, which is, what is that highest point? What's the maximum height that ball is going to achieve? Well, to find it, remember we have to find the y-coordinate of the vertex. So to find the y-coordinate, now that we know the x, you plug it in. Okay. And basically you do the math. So the y coordinate is 74. That means the highest point of this ball is going to be 74 feet. So the vertex is 274. And that means it's going to reach its highest point in 2 seconds. And that high point, the highest point it's going to be is 74 feet. Okay. And this is actually what we do on a day-to-day basis when it comes to missiles and stuff. When we want to intercept missiles, we want to know when it was launched. We want, based on how fast it's moving, we can calculate the highest point. So if we need to intercept that missile, we can do so. Okay. We can also do equations with business with this. So like their profit equations that say, okay, if I make X amount of product, this is going to be the cost. So we want to minimize cost, okay? And we want to know what's the amount of product that we can produce to minimize cost. Okay. So let's do a problem like that. Okay. So the cost of producing X flash drives. So X is the number of flash drives that you produce, okay? And the cost to produce X amount of flash drive is given by this equation. So the cost in thousands of dollars, okay? So we want to find a way of minimizing cost. Well, if we look at it, this is a parabola equation because this is a quadratic. And since it's negative, that means it opens down. And because it opens down, that means my vertex is a maximum point. So when we want to maximize cost, okay? Okay. What is the maximum cost it will take to produce these things? All right. So the vertex is a maximum point. So in order to find the vertex, we have to find what h and k is. So h is negative b over 2a. So that's negative 30 over 2 times negative 3, which if we do the math, gives me 5. That means if I produce 5 thumb drives, that's where I'm going to get the maximum cost. That's the most I'm going to have to spend, okay? And to find what the maximum I'm going to spend, we plug it in. So my maximum cost is $80, okay? My maximum cost to produce is $80, and that occurs when I produce 5 thumb drives. So as long as I produce less than 5 thumb drives, then I won't reach my maximum cost, right? So this is how we use quadratic equations on a day-to-day basis to predict things, to predict how high something goes and where it reaches, or when it reaches that height, or the cost of something, and when that cost is going to be maximum or minimum, depending on the quadratic. So take home point, if you got a word problem where you're asked to find the maximum value of something or a minimum value of something, and you're given a quadratic equation, all they're asking you to do is find the vertex of that quadratic, and you know how to find the vertex, or at least should. And the x-coordinate is where or for what input gives you the maximum or minimum point. And the y-coordinate, the k, tells you what that maximum or minimum value is. Any questions?
No.
Okay. So let's talk about an equation that looks like this. Okay. And I want to find the x-intercept. So I want to find the solution to this equation. So I set it equal to 0 and try to solve. Now, there's a problem with this. The problem with this is the only way you know up to now how to solve this equation is by factoring. Can we factor this equation? Can we factor this quadratic? Are there two numbers that multiply to give me -1 but add to give me 4?
No.
No. So how do we solve this thing? Because it does have a solution, but we have to figure out how to solve it without factoring. Now, the way you factor this, the way you solve this is by using what we call the quadratic formula. And the quadratic formula is pretty scary. Okay. That, guys, is the quadratic formula. Okay. Where A, B, and C are your leading coefficient, linear coefficient, and constant term. Okay. And it looks pretty daunting. It looks pretty difficult, but we'll take it. We're going to break it up into smaller pieces so that everyone can understand it. Okay. Now, the quadratic formula will always give you the solutions or the x-intercepts, always, whether the equation, whether the quadratic is factorable or not. You can always use this formula to find x, okay, given a quadratic equation. Now, therein lies a problem. Whenever I tell students that this formula will work all the time, guess what they do? You guys forget how to factor and say, okay, well, this works 100% of the time. This is what I'm going to use 100% of the time. And that may not be the most efficient way of solving an equation. Because think about it. A car can take you anywhere you want to go all the time. Now, if you're just going to your neighbor's house just across the yard, you're not going to get in a car and go back and from your driveway just to drive down one lawn to drive up your neighbor's driveway. Okay, it's really complicated. You're just going to walk across the lawn. So the same thing here. If you can factor the quadratic, if you can solve the quadratic with factoring, you want to do that. Okay. Now, like in this quadratic, you cannot solve it via factoring. That's when you want to pull out the big gun. Okay. Another analogy I give is, can you kill a fly with a bazooka? Probably could, but that probably wouldn't be the best way to kill that fly, right? There are other better ways. So the same thing with the quadratic formula. Will it work 100% of the time? Yes. But sometimes going down this mess may not be the best way to solve the equation. There might be easier ways of solving it. Okay, so that being said, let's talk about the quadratic formula. So the first part that's most interesting for the quadratic formula is this thing right here. Okay? And it's called the discriminant. Okay. And it's called the discriminant because it discriminates between the type of solutions that you're going to get. So the discriminant is a number. It's either going to be greater, it's either going to be less than 0 or negative. It's going to be equal to 0, or it's going to be positive. That means it's greater than 0. And based on whether the discriminant is negative, 0, or positive, you can tell me what type of solutions, okay? So if the discriminant is negative, you have nothing to worry about. You don't need to do any more with the quadratic equation, because that means that the quadratic has no real solutions, okay? No real solutions. Now, if the discriminant is equal to 0, that means that the quadratic has one solution, or one x-intercept. Okay. Now, if the discriminant is greater than 0, there's one of two options. It's either a number that is a perfect square or a number that's not a perfect square. So remember, your perfect squares are numbers like 1, 4, 9, 16, 25, whatever. Numbers that when you take the square root, you get a whole number back. If it is a perfect square, that means you have two rational solutions. Now remember what a rational number is. It's a number that can be written as a fraction. So your integers, your whole numbers, and of course your fractions. Okay? And if you have a perfect square, that means that you have two x-intercepts and they're both rational numbers. That's like the best situation. Now, if it's not a perfect square, that means you have two irrational solutions. So remember from class what an irrational number is. It's a number whose decimal keeps going. So like pi, or the square root of 2, or the square root of 7. Okay. So that based on what the discriminant value is, I can see whether it is even worth my time to keep going with the quadratic formula. If the discriminant is negative, then I have no solutions and I can stop. If the discriminant is equal to 0, that means I have one rational solution. If the discriminant is positive and a perfect square, then I have two rational solutions. And if it's not a perfect square, two irrational solutions. So, when the discriminant is a perfect square or 0, these are your factorable quadratics. Okay, so when you calculate the discriminant and you get 0 or a perfect square, that means you know that that quadratic can be factored, right? So if you look at a Venn diagram of quadratics, if these are the collection of quadratics, the one that you can factor are these right here. So not all quadratics are factorable, okay? And the factorable ones are the ones with a perfect square discriminant or a 0 discriminant. Okay. So let's look at the problem that I gave you. X squared plus 4x minus 1. So we want to calculate the discriminant. Now remember, before we calculate the discriminant, we have to have one side equal to 0, which we do here. So if you have an equation whose one side does not equal 0, you cannot calculate the discriminant until you do some algebra and make one side equal to 0. So first thing I like to do is identify my leading coefficient, my linear coefficient and my constant term. And then I calculate my discriminant. Just plug it in. Okay. So the discriminant is 20. Well, what does that mean? Well, it's positive. That means I have two solutions. But 20 is not a perfect square. Okay, 25 is, 16 is, but 20 is not a perfect square. That means I have two irrational solutions. That means that this quadratic is not factorable, which we already knew. Okay, so that means we have two irrational solutions. Now, once we know what the discriminant is, we can go and find what x is. So now that we said the discriminant is b squared minus 4ac, the formula for my quadratic formula is negative b plus or minus the square root of the discriminant, all of it divided by 2 times a, which is the leading coefficient. So now we plug it in. Negative b, which is negative 4, plus or minus the square root of 20 over 2 times 1. So now we do the algebra, negative 4, and we can simplify 20 into root 4 times root 5 over 2. So, before we can get a solution, remember how we simplified these things. We said, can we factor out a common factor in the numerator? And the common factor in the numerator is 2. So when we factor out 2, we get negative 2 plus or minus root 5. And remember, since we have both 2's on the outside, we can cancel those out. So these are that's my answer, okay? So that means my solutions are negative 2 plus root 5 and negative 2 minus root 5. Okay. So there's no other way we would have been able to find the values of x, my x-intercepts, without the quadratic formula for this quadratic, because we couldn't factor it. We had to use the quadratic formula. And I know you're probably looking at it like, oh my God, how the heck am I going to do this? But take it a step at a time. Find the discriminant, and then use the discriminant to say, okay, what type of solutions do I expect? Do I expect no solution, 2 rational solutions, 1 rational solution, or 2 irrational solutions? Okay. And then once you find what you expect, then you use the quadratic formula to find the actual solutions. It's negative b plus or minus the square root of the discriminant over 2a. Okay. So let's do another one. Okay. So I want to solve this equation. Okay. So because this is a quadratic, the first thing we're going to do is we're going to subtract 3 from both sides. Okay, because we want one side to equal 0. Okay. Now, we're going to try to see if we can solve this via factoring. So remember, when the leading coefficient is something other than 1, I got to try slip and slide. Okay. But there's a problem. I can't factor this, okay? Because there's no two numbers that multiply to give me 2, but combine or add to give me -5. So since I can't factor this, I have to use the quadratic formula. So the first thing I'm going to do is calculate the discriminant. Okay. So the first thing I want to do is identify my A, B, and C. A is 2, B is -5, C is 1. So -5 squared minus 4 times 2 times 1. Okay. So the discriminant is 17. Well, if the discriminant is positive, that means I get 2 solutions. But it's not a perfect square, so I'm expecting 2 irrational solutions. Okay. Now, we have to calculate what x is. So remember, it's -b plus or minus the square root of the discriminant divided by 2a. So -b, so b is -5, so minus -5 plus or minus the square root of the discriminant, which is 17, over 2a. Now, notice I can't simplify this further. There's no numbers that multiply to give me 17, one of which is a perfect square. And I can't simplify the top anymore either. I can't factor out anything. They don't have a common factor. So this entire thing is my answer. So my 2x values are x equals 5 plus root 17 over 4 and 5 minus root 17 over 4. Okay. Any questions? I know it's a lot of information and the formulas are kind of scary, but if you do a little practice, I think you'll get a hold of it. So tomorrow what we're going to do is we're going to actually do more problems like this. We're just going to do 20 to 30 problems using the quadratic formula and some that do not require the quadratic formula. Any questions about max-min value? So take home point, if the parabola opens up, the vertex is a minimum point, okay? And if the parabola opens down, the vertex is a maximum point, okay? The x coordinate of the vertex tells you for what value of x the maximum or minimum occurs. And the y value tells you what that max or min value is. And of course, this is a quadratic formula. The discriminant is b squared minus 4ac. If it's less than 0, that means you have no solution. If it's equal to 0, you have one rational solution. And if it's greater than 0 and a perfect square, you have 2 rational. And if it's not a perfect square, 2 irrational. I know I threw a lot of information at you. I highly recommend you go back and watch the video a little bit slower if need be. And if there's no more questions, then we'll reconvene tomorrow at 1:30 to do more problem types. And hopefully by doing multiple problems, it'll make more sense. So the key thing right now is to memorize the quadratic formula. Know the formula for the discriminant and know the formula for the quadratic formula. Any questions? All right. If there's no questions, then we will call it a day. And if you need to reach out to me, let me know. All right. All right. Well, there's no more questions. Y'all have a great day. All right.
Have a great day.
Mm-hmm.